I'm Iber Chessy Ochanko and I'm going to discuss the history of nanotechnology. Nanotechnology can be understood as a technology which allows in the controllable way not only to create nanomaterials but also to operate them and to influence them or to use them according to their intended purposes. The word nano comes from the Greek word for dwarf and broadly speaking. The field of nanotechnology can be defined as researches and technology developments at the atomic or molecular level. Researchers in nanotechnology seek to understand and control some of the smallest objects known to humankind.
A Timeline of Nanotechnology, 1959. Feynman gives lecture titled There's Plenty of Room at the Bottom, describing molecular machines with building with atomic precision. 1974. Taniguchi uses term nanotechnology in paper on ion spatter machining. 1977. Drexler originates molecular nanotechnology concepts at MIT. 1981. Drexler gives the first technical paper on molecular engineering to build with atomic precision. Scanning tunneling microscope invented. 1985. Buckyball discovered. 1986. First book published, Engines of Creation, The Coming Era of Nanotechnology by Eric Drexler. Atomic force microscope invented. First organization formed the Forsyth Institute. 1987. First protein engineered. First university symposium. 1988. First university course. 1989. IBM logo spelled in individual atoms. First national conference. 1990. First nanotechnology journal. Japan's STA begins funding nanotech projects. 1991, Japan's MITI announces bottom-up Atom Factory. IBM endorses bottom-up FAT. Japan's MITI commits $200 million. Carbon nanotube discovered. 1992, first textbook published. First congressional testimony. 1993, first Feynman Prize in Nanotechnology awarded. First coverage of nanotech from White House. Engines of Creation book given to Rice administration, stimulating first university nanotech center. 1994, nanosystem textbooks used in first university course. US, Science Advisor advocates nanotechnology. 1995, first think tank report. First industry, analysis of military applications. 1996, $250,000 Feynman Grand Prize announced. First European conference. NASA begins work in computational nanotech. First nanobio conference. 1997, first company founded. Zyvex. First design to nanorobotic system. 1998, first NSF forum. Held in conjunction with Foresight Conference. First DNA-based nanomechanical device. 1999, first nanomedicine book published. First safety guidelines congressional hearings on proposed National Nanotechnology Initiative. 2000, President Clinton announces U.S. National Nanotechnology Initiative. First state research initiative, $100 million in California. 2001, first report on nanotech industry. US announces first center for military applications. 2002, first nanotech industry conference. Regional nanotech efforts multiply. 2003, congressional hearings on societal implications. Call for balancing NNI research portfolio. Drexler or Smalley debate. It's published in Chemical Engineering News. In year 2004, first policy conference on advanced nanotech, first Center for Nanomechanical Systems. 2005, at Nanotech's meeting, Rocco announces nanomachines or nanosystem project count has reached 300.
New brain cells, like nanodevices, work together to identify mutations in viruses. These systems could potentially overcome computational hurdles faced by current digital technologies. Meanwhile, in nanomedicine, researchers at Penn Medicine have discovered a new, more effective method of preventing the body's own proteins from treating nanomedicines like foreign invaders by covering the nanoparticles with a coating to suppress the immune response that dampens the therapy's effectiveness. Nanotechnology's ambition for the agricultural sector is to decrease the number of chemicals lost during spreading or spraying of products such as pesticides and fertilizers, minimize nutrient losses in fertilization, and increase the yield through pest and nutrient management.
Nano-application in medicine. Researchers are developing customized nanoparticles
There are
the size of
certain negative
molecules that can
impacts of
deliver drugs directly
nanotechnology
to
on
disease
environment
cells in your
in many
body.
ways,
In
such
electronics,
as increased
nanotechnology holds some
toxicology
answers for
pollution
how we might
on the
increase the
environment
capabilities of
due to
electronic
the
devices
uncertain shape,
while we reduce
size,
their weight
and
and
chemical
power
composition
consumption.
of
In
some
food,
of the
companies are
nanotechnology
developing
products.
nanomaterials that will make a
Environment
difference
protection
not
is one
only
of
in
the
the taste
critical
of food,
challenges
but
faced by
also
the
in
human
food
race.
safety and the health
Over the
benefits that
years,
food
we
delivers.
have
In
unintentionally
fuel cell,
devastated our
nanotechnology is being
surrounding
used to
by
reduce the
creating
cost of
and discarding
catalysts
plastics,
used in fuel
contribute to
cells to
climate
produce
change
hydrogen
by
ions
mining and burning
from
fossil
fuels such as
fuels,
methanol, and
and
to improve
polluted
the
our
efficiency of
air and
membranes
water
used in fuel
ways
cells to
with
separate
human-made
hydrogen
creation.
ions from other
But
gases
now,
such as
it is the time
oxygen.
to repair the environment
In
and
solar
our
cells,
relationship with it
companies have developed
with
nanotech solar cells that can be
technology set to
manufactured
play
at
a vital role
significantly
in
lower cost
securing the
than the
future
conventional solar cells.
sustainability of
In
our planet.
battery, companies are currently
Why
developing
nanotechnology?
batteries using
Nanotechnology
nanomaterials.
exhibit
One such
unexpected
battery will
properties
be good a
compared to
year
their
after
black
sitting on shelf for
counterplants
decades.
counterparts.
Another
Their high
battery can
surface
be recharged
area to volume
significantly
ratio
faster than the conventional
imparts unique
batteries. In space,
psychochemical
advancement
properties,
in nanomaterials
including
make lightweight
versatile
spacecraft and the cable for the
functionalities
space
and
elevator
enhanced
possible by
reactivity of
significantly reducing
selectivity.
the amount of rocket
From
fuel
saving raw
required.
materials,
These
energy, and
advances
water
could lower
to
the cost of
decreasing
reaching orbit
greenhouse
and
gases
traveling in
and
space.
dangerous waste,
In chemical sensor,
nanotechnology's unique
nanotechnology can
attributes can
enable
be
sensors
utilized
to
in
detect
various
very
products,
small amounts of chemical
produce an
vapor.
application
In fabric,
that could
making composite fabric with
undutable
nano-sized
support
particles or fibers allow
environmental and
improvement of
climate
fabric
protection.
properties without a significant increase
These are the
in weight,
societal
thickness, or
advantages of
stiffness as might
nanotechnology:
have been the
less
case with
pollution,
previously
mass
used
production of food
techniques.
and consumables,
Nano-application
and
in
low
medicine.
production costs.
Researchers are
These now
developing
are the societal
customized
disadvantages of
nanoparticles, the size of
nanotechnology.
molecules that can
First
deliver
off, they are
drugs
dangerous,
directly to diseased
highly
cells in
cost,
your body.
and job
In
loss.
electronics,
It is dangerous because
nanotechnology holds some
counterfeit
answers for
weapons
how
can
we
now
might
be made more
increase the
easily and
capabilities
accessible.
of electronic
It
devices
is highly
while
cost
we reduce their weight
because
and power consumption.
ex-
In food,
developing
companies
it
are
can be highly
developing
costly. It's also hard
nanomaterials
to
that will
create, and
make a
which is
difference not
partly why
only in the taste of food,
nanotechnology-based
but
production are
also
more
in food
expensive.
safety and the
Job
health
loss: because
benefits
of
that
the
food
traditional farming and
delivers.
manufacturing
In
industries
fuel
may lose
cell,
jobs as a result of
nanotechnology
its
is
own
being